Chapter 3, problem number 5. Let me read the question first. A ball is thrown horizontally from the roof of a building 45 meters tall and lands 24.0 meters from the base. What was the ball's initial speed? Okay, here we are on the roof of a building. Here we are, and we're going to throw a ball off the roof. And the ball, of course, is going to fall down, and it's going to land 24 meters from the building. So it'll look something like this. Land right here. They go out and measure it. It's 24.0 meters, and we know the building is 45 meters high. 45.0 meters high. So from the ground to the top of the building is 45 meters, and it went out 24 meters. The question is, what is VOX? How fast did we throw it off the building? Let's look at the y direction first. If we use the equation of motion for y, we get y equal y naught plus v naught y t plus 1/2 a of y t squared. Now, we know that y naught is equal to 0 because that's where it started from. We know v naught y is 0 because he threw it horizontally. There was no vertical part to this throwing. He threw it horizontally. So VOY is 0. And A of y, the acceleration in the y direction, is due to gravity, or g. So if we plug that into this equation, we get this goes to 0. VOY t goes to 0, leaving us only this part of the equation left. Substituting g in there, we get y equal 1/2 g t squared. Now we have y was given. What we're doing is trying to find the amount of time so we can use the time to go back into the x equation. We rearrange it algebraically. T equals 2y over g. 2 times 45.0 meters divided by 9.80 meters per second squared. Take the square root, and you'll get on your calculator some number that looks like 3.0304 seconds. We're going to keep the whole number for now, and we'll only round off at the end. Now we're looking the x direction. The equation of motion for the x direction is x equals x naught plus v naught x times t plus 1/2 a of x t squared. X naught is also equal to 0 because that's where we start from. A of x is always equal to 0 for any horizontal or projectile motion. Always in the x direction, it's always equal to 0. And t is given from the previous page is 3.0304 seconds. We calculated that. Then we can put this in the equation. You see x naught goes to 0. A of x goes to 0, leaving only the v naught x t left. So x equals v naught x t. This is the one we want to find. We're trying to find v naught x. So we rearrange the equation. V naught x equals x divided by t. X was given as 24.0 meters. T is what we picked up from over here, 3.0304 seconds, equals 7919595 meters per second. Again, that's too many numbers. We know we started with 3 significant figures here, and they have more than 3 here, so we use the least amount, the smallest number. So we want to round off 791. You see that it's a 9 here, so we add 1 here to 2, and we'll drop these other numbers, round off, and our answer is VOX equals 7.92 meters per second. So our answer on our diagram is 7.92 meters per second. And we've solved the problem.